Hi guys, and welcome back to another number systems edition. In this calculation we will be having binary division, and we will have the values 44 and 3, and we will do division with those two values. Right, but what we need to do first is we need to take 44 and we need to take 3, put it into this code system, and we need to get the binary equivalent for both of those values. Right, so if you got that, the next thing is you need to do is you need to do the division calculation as I've done here. Right, what you need to do here is when you have the value of 3 here, you need to say you will take that as a whole, which is 3 in decimal, and you're going to divide it into each digit which I have here until you have the digit or the number big enough here so that 3 can actually go into that specific number. Right, so 3 goes into 1 0 times. I'm actually going to stop there when I have a 0 there, because when I multiply anything with a 0, I'm going to get 0, and I'm going to make this calculation even longer. Right, so I stop there. 3 goes into 1 0, which means I'm combining these two now, and if I combine them, these two digits will give me 2. So 3 goes into 2 0 times. I'm going to stop there again. I'm at the third digit, which I'm combining with these two, which means 1 0 1 will give me 5. So 3 goes into 5 once. 1 times 3 is going to give me 3, and 5 minus 3, which is 1 1, is going to give me 1 0, which is 2 in decimal. The next thing that I do is I bring my 1 down, which means if I combine that with those two, it's going to give me 1 0 0, which is again 5. 3 goes into 5 once. 1 times 3 is going to give me 3, and 5 minus 3 is going to give me 1 0, which is 2 again. Next, I'm bringing down my 0 here, and I combine it with those two, which means if I combine it, I'm going to get 1 0 0, which is 4 in binary, and 3 goes into 4 once. 1 times 3 is going to give me 3, and I have that 4 minus 3 is going to give me 0 1, which is 1. The next thing that I do is I bring down the 0 here, which means this number will actually change. 0 1 0 is now going to be 2. So 3 goes into 2 0 times 3 is going to give me 0, and there I can see that I'm going to have my binary value here at the top, which is my answer, and I'm going to have a remainder of 2 in decimal. So what you do then is you take that value and you put that value into your code system. There you can see that 8 plus 4 plus 2 is going to give me 14. And then to see if you're correct is that you will say that 14 multiplied by 3 is going to give me 42. And 42 plus this remainder of 2 which I have left here will give me 44 at the end of the day. And that is how you know that your calculation is correct. Let's go to my second example. Right, in example number 2, we're going to have 56, which we're going to divide by 5. The next thing that you need to do is, or the first thing that you need to do is you need to take those values and you put it into your code system so you can see what is the binary equivalent. And after that, you can start dividing those two values into each other. Right, so let's go to the calculation. Here we can see we have a bigger value now in the sense of 5, in the sense that it has 3 digits. So let's see how we do this. Right, 5 goes into 1 0 times. 5 goes into 1 1, which is 3 0 times. I stop there. 5 goes into 1 1, which is 1 1 1, which is 7 once. 1 times 5 is going to give me 5. 7 minus 5 is going to give me 0 1 0, which is 2. I bring down the 0, which means this binary number changes. 0 1 0 0 is going to be 4. 5 goes into 4 0 times. 0 times 5 is going to give me 0. and 4 minus 0 is going to give me 4. I bring down the next digit, which is 0. Number changes to 1000, which is 8. 5 goes into 8 once. 1 times 5 is going to give me 5, and 8 minus 5 is going to give me 0, 1, 1, which is 3. I bring down my next digit, which is 0, so this number changes to 0, 1, 1, 0, and that's going to be 6. So 5 goes into 6 once. 1 times 5 is going to give me 5, and 6 minus 5 is going to give me a remainder of 1, which is 1 in decimal. The next thing that you do is you take that value, that binary number, and you put it into the code system, and you see what is the actual value in decimal. So that is going to be 8 plus 2 plus 1, which is 11. And then you say 11 multiplied by 5 is going to give me 55. And 55 plus 1, which is the remainder, is going to give me 56. Right, let's go to the next example. Right, in my last example, we're going to have 28 divided by 9. Again, first things first, take 28 and 9, put it into your code system so that you can see what is the binary equivalent for 28. So that one is the binary equivalent for 28, and the binary equivalent for 9 is that number which you have there. Alright, after that has been done, now you go to your actual calculation. Here we're going to say that 9, we take that as 9. Although it's the binary code, remember, we will take the decimal number 9 and we will say it goes into that specific digits which we have on the side here. So 9 goes into 1, 0 times. I will stop there again. The reason for that, and I'm going to say it again, is because 0 times anything is going to give me a 0, and then it's going to make this calculation very long. The next thing that I do is I combine the second digit with the first one, and if I combine that, that is going to give me 3. Right, so 9 into 3 is going to give me 0, 0. I will stop there again. The third digit I will combine with the first two, and that's going to give me 7. So 9 divided into 7 is going to be 0 times. Stop there again. I go to the fourth digit and I combine it with the first 3 digits, and that will give me 14 if I put it into my code system. So 9 into 14 is going to go once. 1 times 9 is going to give me 9, and 14 minus 9 is going to give me 5. Alright, so the next thing that I do is I bring down the digit here, which is 0, which means this number, binary number, will now change. So that is 1010, which is 10 in binary, and 9 goes into 10 once. 1 times 9 will give me 9, and 10 minus 9 is going to give me 1. Alright, so there I have a remainder of 1. The next thing that you do is you take that value and you will put it into your code system, and there we can see that that number is 2 plus 1, which is 3. Then you say 3 multiplied by 9. Remember, this is 9, so the decimal number for 9 is, or the decimal number for this binary number here is 9. So 3 multiplied by 9 will give me 27, and 27 plus 1 will give me 28. So that is how you know that you have calculated correctly. So in actual fact, this binary answer is 3 with a remainder of 9. Thanks for watching.